Navier Stokes is going to be put in 5 simply because of the way it looks. Is that how we conduct ourselves as physicists? Report for obscene content. Today, if you are joining us now, we are going to be doing the ultimate tier list of physics equations. I have 22 of the most famous physics equations, and we are going to be ranking them from S down to D. The way we're going to do it is when we start, I will be starting up a poll, and you will have to vote on what you think, where you think that physics equation goes, and then we'll talk about it, and ultimately I will decide, influenced by physics chat, physics Twitch chat, whatever that means. So for starters, we're looking at the action integral as the first equation up. This is going to be summed up as the least action principle, and this is the action integral. And what this means is basically that an object without any external influence will take the least, the shortest path through space. And we've derived that on one of our series on the YouTube, the Lagrangian Mechanics series. But it's obviously guided the way for probably the most famous of all, maybe most infamous of all formalisms for quantum mechanics and also QFT. I think this is an S tier because it led to the path integral formalism. And I think path integral formalism is what we do. Alan, there's no zero. The path integral formalism is ultimately, I think, what kind of shaped quantum mechanics and quantum field theory. I'm just gonna go lower than Eric every time. Why? Don't you trust my opinion? Okay, let's stop the voting. I think we're gonna go S tier with this one. You can tell how nerdy we are by how many things we put in S tier. S tier has got to be like the best of the best, though. You know what I mean? Like, has to be 100% cream of the crop equation, right? All right, next up is Bernoulli's principle. Bernoulli's principle is basically that the pressure, you have pressure in one part of a, we'll say a section of pipe or a section of occupancy. I don't know what you want to call it. Some area of something. And then we have the velocity times the density, and then the density times the force due to gravity and the height. Again, this is a very basic equation. This is not like, there's other variations of Bernoulli's principle. We won't get into the different variations. This is just one of them. Bernoulli's principle is lower for me. I don't know why. I think that might make some people sad who love it. It's so non-committal. What does that mean? Non-committal equation? This one seems a little bit more split. I'm not sure where I'm gonna go with this one. It's not S tier. I just don't believe it. I don't believe it to be S tier. I might go with number 4 on this one. And Bachman suggested it, and he also went number 4. And I feel like it's a safe bet to say that this one's ranked C. All right, it looks like the voting is in. I am gonna go ahead and put it in the C category because that did get the most votes. And it was, in fact, my vote as well. So let's go. We are putting you in C, Bernoulli. Next up is Biot-Savart. Of course, Biot-Savart is the way that you usually find a magnetic field. Now, the things in this are the vacuum of permittivity for a magnetic field, I for the current, ds for a segment of a wire, a segment of length of wire, and radius, a distance away from that wire, but moreover, it's not just a distance, it's a direction. Notice how it's a unit vector. And then over r squared, which is an inverse square law. Biot-Savart does have some special cases like Ampere's law. Ampere's law is a special case of Biot-Savart, and Ampere's law is highly important to a lot of physics of magnetism. Biot-Savart also can be written as a different form with Q and V's instead of I and DS. We talked about that. I don't think it was last week. Maybe it was the week before. So it looks like people are voting for a solid B on this one. I kind of tend to agree. I don't think it's down where Bernoulli's is, let's be real about this. But I do think that it's, it's not, I don't know if it's A. I don't know if it's A quality, and it's certainly not S. I think we can all agree that this is not S quality equation. So it looks like we're at a solid B. All right, let's put it in. Send it away to the B's. Next up, you have one of my favorites. The Dirac equation. Let's get that one up here. The Dirac equation. The Dirac equation is famous for trying to unite quantum mechanics with the Einstein, the one we talked about, the Einstein relativistic energy equation. And the goal was to take the Einstein energy equation and to factor it, because you could factor it. What happened was they tried to solve it using certain rules, and time did not behave nicely. So you either got the Klein-Gordon equation or the Schrodinger equation. And if you wanted to have something that was relativistic, you could do the Klein-Gordon equation, but it didn't work with every field. There were fields where it didn't work. And the fields that it didn't work ended up being subjected to the Schrodinger equation, where it was time independent or time dependent, depending on it. But it was different, completely different. Now, this is where we might part ways, chat. This is where I might call the mulligan card. I might have seniority over this, because this is why. I don't think this is S-level tier. Think about the stuff that happened with this equation. I mean, it's really good. It's a really good equation. So far, it explains pretty much every Dirac fermion, right? Which is pretty much all of them. But is it really on level with least action principle? Is it really on level? It'd be a little bit more generous than that, Admiral. Like, we don't have to, not just a particular field equation. It is the root of Einstein's energy momentum relationship. But I don't know, I might rig this one. I will give myself 3 chances to change the outcome of a poll. And I think this is one of them that I'm gonna change. I think we're gonna go A on this one. Dirac equation, brilliant equation, excellent. Just, I don't know if it's on the level of the action. Next up, we have Einstein's field equation, Einstein's general relativity equation. Now, hear me out. This equation is pretty big. Like, think about all that is in this equation, right? We have the shape of space on one side, and then energy density on the other side, mass and energy density on the other side. It has a lot of physics in it. I'm gonna vote S tier, but I am gonna see where this poll goes. I do think that this is S tier quality. The entire field of cosmology comes out of this equation. It's true. It's one of the 2 pillars of physics. Yes. And I think that that's why I'm comfortable saying this is a very comfortable S tier. No metric. Can I change my vote? No, voting's done. This one is supremely voted an S tier. I agree. Next up, though, we do have Einstein's relativistic energy mass equation. This one I'm a little less familiar with. I think that the E equals MC squared thing is overhyped. I don't think this is S tier. I just don't buy it. Is it A tier? I'm not sure. I know that ultimately it led to solutions like the Schrodinger equation, the Klein-Gordon equation, the Dirac equation. So to me, I do think that this is A tier, but I'm not convinced. It's good, but like, I don't know if Einstein actually even struggled with this. Maybe this was like he just saw the diamond in the rough, and just got lucky. I want to say maybe he just got lucky with this. Whereas general relativity, there was no luck. That was just brute force. You know what I mean? Like, that was crazy. That was crazy. But E equals MC squared for like a particle at rest? I don't know. I might say A tier because of what it came out of it. He did a bunch of light stuff, and I feel like he was sort of piggybacking on the light stuff, whereas special and general relativity, they were like, I think I'm gonna go with A. I'll let you guys have this one because I'm less convinced. I'm less convinced, but I will believe you that it goes with A. Next up, we have Boltzmann's entropy. The famous entropy is equal to the Boltzmann constant times the natural log of, what's that? Omega. Is that the macro states? Basically what this says is how many ways can you rearrange atoms inside of their inside of the macro arrangements. So there's, obviously there's think of a group, think of all the places the atoms could be, and then think of how many times you could rearrange the atoms into that. That's what this omega is. And it's basically telling you the entropy of the object. S, you guys are going S on this? I don't find this an S tier category. I don't see it. It was on his gravestone, so he obviously loved it. He loved this equation. Really? A's and S's? No way. Oh man. Do I have to pull rank on this one? Ooh, there's a couple on here that I want to put low though. And a couple that I want to put higher. Then I think you will vote for. Ooh, but I don't want it to be an A. I think that's too high. I think it is an S tier. So much physics contained in that and information theory. Yeah, but like how fundamental is it? Like, ooh, I don't know. Black hole thermodynamics. Good point. Good point. Maybe I'm just a fanboy of talking about entropy as quantum mechanical entropy. Mutual information. Ever heard of it? You know what I mean? Like, and this whole thermodynamic stuff, just, man. All right, I will let chat have this one. It goes A for you, but we have to start ranking things lower. We're too nerdy. We're way too nerdy. Look at how high we're ranking everything. It's not, we need to do better. I don't like thermal, but connecting entropy with probability was a big brain move. Why is the sky blue? This is why I went with that. That's an excellent comment. That's an excellent comment. Here we go. Next up, we have, okay, the Euler-Lagrange equations of motion. This one's big. This one comes from the S1 though, so not that important. Ooh, is it not that important? I mean, out of this one, this is a little bit tricky with this one because we also have Emmy Noether's stuff coming up too. So keep that in mind. This one I'm counting separately from what Emmy Noether did. But conservation laws do come out of it, and I think that's how we're taught nowadays. So the Lagrangian has two terms, as a kinetic minus the potential, and the idea is that if you change small variations of the Lagrangian, you want to know what happens to the energy, right? Ultimately, I pick everything. Let's just be real about this. This is my show. But I will let you guys pick some too. I am gracious. I am giving. Way to encourage participation. Listen, I have gone with what you guys have said almost every time except for one. I've only pulled rank once. Just once. Otherwise, I've let you guys decide. Is it A? Speaking of pulling rank, I will not be putting this one in A. I don't see the Euler-Lagrange equations of motion being an A by themselves. I don't think by themselves the Euler-Lagrange equations are a B. That's right. We're dropping the Euler-Lagrange equations of motion down to C. I just disagree. If I were to lump them with the Emmy Noether's conservation laws, then yes, they would be an A. The spoiler alert. Speaking of that, let's just skip to Emmy Noether's stuff before you guys have a riot against me. Emmy Noether's differentiable symmetries equal conservation laws. This comes from that equation. I think this one's huge. I will let chat decide this one. I will not participate in this one. We will let it go for a little while longer, but I am torn. I am torn about what, and I'll tell you why I'm torn. Because I don't know how absolutely necessary Emmy Noether's theorem actually is for physics. You know what I mean? Like, could you get away with just doing it a different way. Euler Lagrange Equation C tier. Why are you commenting on only the ones that I pulled rank on, LeviewBot? This is not right. Those are not. It's not a big yikes. We're tied right now. We need a tiebreaker. Am I gonna have to be the tiebreaker? Oh, Koopa tie broke it. Tie broke it? Broke the tie? And then Linux brought it back for the tie again. And Stealthy put it into A. Euler Lagrange Equation is literally the start for field theory. I don't know, man. Are they, or is Noether's theorem? Because the way I was taught was that Noether's theorem is the start for field theory. I will give a final 10 seconds if anybody wants to cast another vote that's sitting there quietly, unable to decide whether or not it's an S or an A. But I have not voted, and I will not vote unless we get into a tie. Parzival. Voting is closed. We are going with the A. Oh man, you guys are a spicy bunch. Next up, we have Gauss's law. Of course, the famous intuition that Gauss had, that if you had an electric field and you enclosed it in some area, then it could talk about the charge enclosed for just that area. Right with Biot-Savart, it's kind of along the same guys as Biot-Savart, isn't it? That it would be there. Hard to say. This one's certainly a little bit more torn. Looking at B's and C's a lot, we have a couple people with S's and A's. I mean, just sheer intuition that Gauss had to come up with it is wild, right? Like, that's super impressive. But you also got to think that Gauss came up with a lot of weird things too. Like the whole summing up over numbers 1 to 101. Like, you know, like, okay, whatever. Weird flex, man. You know what I mean? Like, it's definitely a weird flex. I think I agree with Jack. I think this is handedly a B. See, I do find this different than our next one. I will skip ahead a little bit to our next one, because our next one's a little bit different, and the fact that it has Gauss's law in it. But of course, now we're going to be talking about, where are they? The famous Maxwell's equations. Justin with the B for Maxwell's equations. Wow, bold move, chat. Bold move. Okay, we're A and S are pretty close. You're torn between 1 and 2. I'm a little torn between 1 and 2 as well. I actually am going to vote on this one. I'm going to add a little chaos to the realm. I want to go 2 on this. I don't think that Maxwell's equations are S tier. I just don't buy it. But you got to think at the time, they were very, very impressive. Very impressive. It's 6 to 7, S's to A's. A might take it. I voted for A, and I'm not going to pull rank on this one. I will honor the chat. Yeah, I'm not convinced it's S quality. I'm just not convinced. I do think that Maxwell did great work with him, but I just don't buy it. We're going to A. Next up, we have Heisenberg's uncertainty principle. I hope I spelled that right. Heisenberg's uncertainty principle is a mathematical artifact that we have 2 non-commuting observables. This includes energy and time. Both of them here. Now, here's the cool thing about this, though. The intuition is just gone when this came out, right? Nowadays, we have some pretty big 5 heads, right? And we know that the intuition of what this means, we have a better understanding of what the intuition means. But at the time, just the wildness, just the sheer chaos, sheer chaos, spreading the Heisenberg hate with an early 5. It's like a wrestler, and he hit him with the Heisenberg hate. Honestly, the delta E, delta T feels even more significant. Yeah, that one's included in this. It's included in this bunch. If you just said delta X, delta rho, then I'd be like, that's probably a big old D. Drop it down. I gotta stop saying that phrase. It's last. It's last on the list is what I meant by that. I want to do, okay. Here we go. Let's do a coin flip. This is the only way. Here we go. Heads, it's an A tier. Tails, it's a B tier. Okay, which B is an average. We'll just average it together. B is average. Heads, A, tails, B. Leave it to fate. A it is. I disagree firmly, but I gotta save mine. I gotta save my next one. I gotta save it. Next up, Klein-Gordon equation. Of course, the solution to Einstein's energy. It has to be the same level as Dirac. I firmly disagree. I do not believe it has to be on the same level as Dirac. I am not impressed with the Klein-Gordon equation. I am not impressed. Listen, I told you I would pull rank, and I'm pulling rank. Just because it's rewriting of twice of Dirac's. I don't find this one appealing. That's 3 times pulling ranks. This will be my last time. You may disagree with me. In fact, judging by the voting, I can tell that you're very much disagreeing with me. KG did come before Schrodinger's equation. Actually, KG is what led Schrodinger to doing the Schrodinger equation, because I don't know who did the exact Klein-Gordon equation, but I thought Schrodinger did it. I thought it was a variation of some work that Klein and Gordon did or something like that, and then he just named it after them or something. Twitch chat, I'm sorry. Kyron Wolf. Let's go. That's it. So shall it be written, so shall it be done. The Klein-Gordon equation is unimpressive. Unimpressive. Next up, Kepler's laws. I think Kepler's laws are a solid D. I only picked the last one because that was the only one I could really find that was a good equation for him. But these are basically like orbits. Like orbits. Whoa, fives in chat. Listen, you have to give him credit though. You have to give him credit. In his time, it was an amazing thing to do, in my opinion. These just come from the Euler-Lagrange, don't they? I'm pretty sure they do. Yeah, I'm pretty sure they just come from Euler-Lagrange equations. I was not going very high with this. I don't think it's A. I was good with a C. If chat votes for a D, they do. I mean, we have C and D are tied right now, 4 and 4. I'm okay putting this between C and D. I'm out of gimmies. I cannot change the outcome by forcing you all to change. Maybe we can coin flip a couple times, but I am fine with just dropping this one in D category and moving on with life. We have 5 to 5 for choices C and D. In his time, it was great and inspired Newton, but now pretty cringy, right? Now it's pretty cringe. Kepler didn't even get the data. Tycho Brahe did most of the hard work. So we should just steal him of that by giving him a rank of D, right? I guess I haven't voted yet. Maybe I should vote to break the tie. Maybe we should let coin flip. Where are we at? Okay, leaving it up to a coin flip. We will leave this up to a coin flip. Heads, unless someone votes before the coin flip is done. Heads for answer C. Oh, Lobo comes in with a salvation for Kepler's laws. I was going to say heads, C, tails, D. Let's see what would have happened. We would have gone to C. So, it is written. Chat has spoken. Kepler's third laws in a C. Oh, we have to rank them this way too. Oh, I forgot to do that. Uh-huh. Uh-huh. Oh. Uh-huh. And we're good. Kepler's third law is better than Klein-Gordon. Riot? No riot. No riot. In his time, it was way better. Way better. Way better. Klein-Gordon. Klein-Gordon is a series of failures and just trying to salvage whatever comes left of it. That's what Klein-Gordon is. The judge has spoken. Next up, the Lorenz factor. This is kind of including the metric and kind of including special relativity. Pretty much everything special relativity. The Lorenz factor, including everything for special relativity. Okay, we have the metric in there too. We have some people who are not convinced. We have a C out the gate. We got a B as the first vote. Look at that. This is gonna be a little contentious. Nobody's going S tier on this, really. We already have GR S tier. This is just a special case, so surely it has to be lower than that. Well put, Airsofter. Well put. I agree. I don't find it S tier. I find it at the top of A tier, though. Maybe behind Maxwell's equations. I just don't find it beautiful. What's the letter under the V anyways? If not 1. Gotta be up there with Maxwell's. I agree it's gotta be up there with Maxwell's. Slightly behind Maxwell's. Special relativity is pretty neato, but the equations don't look pretty. Oh, I didn't know this was a beauty contest, people. I don't remember when this turned into a beauty contest. It's about efficiency, and it's about the time. I do think there's something to say about special relativity with the time of its discovery. Pretty wild, but this is called a Lorenz contraction for a reason. And it all sparks off of a Galileo transformation.
A few moments later.
Like, is this another thing that Einstein was sort of just like yoinking around? It's not a beauty contest, just look at the host. The nerve of some people. This should be higher than Maxwell's, as it also defines the metric. Oh man, the metric's a beautiful thing. I think we're gonna go with Twitch chat on this. I think it's a solid A. Gonna go with A on the Lorenz factor. We're gonna put it ahead of Maxwell's. Next up, we have, wait, what are we voting on? Is this live? No, it's not. Next up, we're voting on Navier Stokes. They're sloppy, I'm sorry. I wasn't about to LaTeX these, okay? I wasn't about to LaTeX them, all right? I didn't want to, so I just found a picture. Ugly. Get it out of here, physics man. Get it out of here. How on earth? Listen, no, listen. This isn't even a good Navier Stokes equation. This is just like a Navier Stokes equation. Gross. Gross. I can't take it. You guys' reaction's so good. Listen, Navier Stokes, everything you need to know about fluid motion. Kind of a big deal, right? Fluid dynamics, viscosity, ever heard of it? Turbulent versus laminar flow. If you haven't heard of it, I have a YouTube video on it. It's pretty good. I basically mixed and unmixed the solution. It was really entertaining. You go give it a subscribe to my YouTube channel. Check that out if you want. Anyways, Navier Stokes, hugely important to a lot of fields. And you guys are all like, go, drop it down to C or D. We don't, get it out of here. It works, but I feel dirty. Destin Sandler has entered the chat. D is gonna win this. Navier Stokes is gonna be put in 5 simply because of the way it looks. Is that how we conduct ourselves as physicists? Report for obscene content. So right now, as it stands, it is 5-5. I will give it a few more seconds for someone to come in and just steal it away. But in the meantime, I think we're gonna have to go to a coin flip on this. Oh, there it is. I think chat has spoken. IlMangoBot came in and said, no, absolutely not. Get this Uggo out. Navier Stokes, a healthy D. We're going to put it behind Klein Gordon. I mean, I have morals. All right. Newtonian Force. Newtonian Force is the next one. An audible boo can be heard from across the land. What do you think? Newton. Like, what does this even mean? There it is. Get it out of here. Starts off with a strong D. Wait, what's going on? Where's the S's and A's coming from here? Whoa, 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 whoa. Everything generalizable is DT. An absolute classic. A classic. Oh, man. It is the original. Like, you know, it is the original. You have to pay respect where it's due. If we said Navier Stokes was bad because it's long, then this is S tier easily. We're not ranking on the size. We're ranking on the how it's used. I'm not convinced. I had a lecturer who would always write it as F equals AM. Oh. All right, listen. We have a few more seconds left in the voting. If nobody votes in the next few seconds, then Newton's ugly law is going to be going into the S tier. Newton's ugly, outdated law that nobody likes is going to be going into the S tier instead of the C tier where it belongs. Boring. Force equals dp dt. Could have done it with Lagrangian mechanics anyways, and it's much cleaner and nicer, and everybody loves it. Nobody needs to vote. Nobody's voting for C. Dang it. You win this one, Twitch chat. Get up there. I'll go. How can I put it down here? Come on. Please. Please. Dang it. All right, it is what it is. All right. What do we got next? Oh, Newton's gravity. Oh, you want to talk about Uggo? I don't think it works that well, to be honest with you. You know what I mean? It's like, how many times? The OG, is it really the OG though? I mean, it's really just a specialization of F equals ma, right? You know, it's kind of cringe. If I had to say an equation is cringe, I would say it's this one. I would use it before using Einstein's relativity. But let's be real, you know, like gravitational potential energy is pretty cool. It's all right, I guess. A little bit weird with the signs and everything. Equation for undergrads and astro students. Okay. All right. I get it. It looks like it's going to be a solid B though. I don't know if anybody's going to be able to, if people are going to be able to bring this out of the B tier, but it got us to Mars. It does okay. It does okay. I'm not going to lie. I'm not impressed with it, you know, but it works. I mean, the OG comment though, I get the OG comment. I mean, it sort of was the one force law that they knew for a long time and was used to understand quite a bit of the solar system. True, but also lame. Where do we put it though? At the end. Handsomely at the end. In fact, if there's anything gonna go in between, it should go in between. All right, next up is Ohm's Law. Let me reset the poll. Everybody knows this one, this classic equation right here. V equals IR, which is the relationship, right? The resistance is the ratio of voltage with respect to current. This one's a spicy one. Look at that. It's tied for A and D. It's not even close. I might have said B. Maybe C even. Imagine the practical implications from this. Computers, sensors, etc. For real. This is voltage through a resistor, people. This is important. 3 variables equals Z tier. Too many variables. Get it out of here. A solid B. Oh, man. Physics coming in. Can we get it out of the D tier with... I don't know what to do. I haven't voted yet. I feel like being a little spicy and going for A, and then we'll have to do a coin flip. You don't belong here. Too fundamental to not give it an A. It's a solid equation. Heavily involved in pretty much anything electricity and magnetism at some level. If nobody votes in the next 10 seconds, then I guess D wins. So I'll give it a few more seconds to see if somebody votes. If nobody votes, then it's going to end up... Oh, snap. And look at that. It's tied for B and D. Wow. What do you know? Tied for B and D. So I guess we got to take it to a coin flip, don't we? Let's see and average it out at a C. Coin flip time. Heads, the answer is B. Tails, the answer is D, unless someone votes in the next few seconds. Heads, the answer is B. Tails, the answer is D. Only Dest comes through. Wait. Did they come through or did it just get tied again? No, they came through. Let's see what it would have been. I would say it's a healthy B. It would have been if only distance saves. It would have been B anyways. Listen, you know, the physics lords have spoken. Also Twitch chat. This is a solid B. We're gonna put it above Newton's garbage, you know? Anyways, next up, we got a couple left. Schrodinger's equation. Here we go. We've seen different variations of this between, and this is including both time independent and time dependent. Wow. Right into S tier. The Schrodinger's equation. Justin, wait, what's going on? Everybody stop. Wait. Hold the phone. You think that the Schrodinger's equation is on the level of the action and Einstein's equation? Okay, well, all right, let's be real about it. It definitely goes above this, but this was a mistake. Before this ends, I'm just gonna do this. You know what I mean? Like when this is over and the day is done, I'm just gonna do that, and I'm just gonna do this. You know what I mean? And then but then it won't go here. Then it doesn't go in 1 anymore. Then the Schrodinger equation is a solid A. A healthy A. It's a good A. Wow. 10 people voted for it. How can I get around that? It's so elegant. Oh, here we go with the beauty contest thing again. You guys put poor Navier Stokes, the thing that tells everything there is to know about fluid dynamics, down in D, but no. All right. You guys have your S tier. You get the Schrodinger's equation. Next up is just a small equation, very beautiful, very small. Standard model Lagrangian. You know it had to be in here. This is the theory. Well, it's not theory of everything, but this is the theory of everything that we know. This beauty, this long, elegant, well-established, perfect notation equation tells us everything we need to know about the standard model of particle physics. Why not just expand out the Einstein while you're at it? It's true. It's a flashy equation meant to scare away people. It's never really used this way, but it is here for the memes. Not S tier, but cool on a t-shirt. Again, cool on a t-shirt. Listen, if this is going to describe the standard model, then it's got to describe all of the standard model, or I'm going to vote for D, okay? I will. I swear I will. Don't tell me that this is the Lagrangians, that this is the Lagrangian that describes the standard model, but I can't take it for all of the levels of perturbation. But the derivation with muons is less than 5 sigma and just indicates extra, but less than 5 sigma, it's 4.2. No, we can't. Missing dark matter though, true. But dark matter might be missing from general relativity. You never know. Justin, you never know. But the derivation, okay, so the deviation with muons is less than 5 sigma and just indicates extra parts to add rather than something wrong. There is no Mond. I admit, I said that to stir up controversy. Vote looks to be D. What's all this S talk? I smell corruption. I'm just giving people time. If anybody wants to vote and change the outcome. All right, the tallies are in. S just got another vote. It's over. The standard model Lagrangian finds its way down to the S tier. Okay, the last equation is a goodie. Still better than Klein-Gordon. Yeah, let's be real about it. Pretty much relating force to electric field, the velocity of a charge, and magnetic field. I would say this is a good one to end on. The last one, it's a goodie. It's not spicy. It's like everybody kind of loves it, you know? Lorenz equals good boy. I would say it's a very comfortable B. You know, I think this one, we can all end on a good note. I think this is a comfortable B, maybe in the middle of the road. I don't feel bad about that. You know, of course, this one's very useful to a lot of things. Like you see it for a long time in electricity and magnetism classes, right? The voting on this one's starting to look like normal distribution. I know, right? We need one person to vote for A, and then one person to vote for S and one to vote for D, and it will look really good, I think. Have a nice... I'll start off the festivities. I'll vote for A. No, I'll vote for A. There we go. Now, if someone wants to vote for S and one vote for D, we'll get a nice distribution to end on. And it will look good. Look at. Here's the voting. There we go. We just need someone to vote D now. And then we'll end on this nice distribution. I think it's really good. There it is. Finish the poll. Look at that. We came together. We united as one to agree that the Lorenz force law is a very healthy B. Right? Very healthy B. We have united chat and Strimmer together as one to show that the Lorenz force law is a B and that these equations are now ranked officially by our community. Well done, everybody. Well done. And with that, we wrap up our segment on the tier list. Congratulations, everybody. You did it.